A Java Lambda function inside a virtual private cloud can incur 8 to 12 seconds of initialization latency. This delay, known as a cold start, directly impacts user experience and service-level agreements. The root cause is the environment setup, downloading the deployment package, spinning up the execution environment, and running the initialization code outside the handler. We are targeting sub-100 millisecond response times for all synchronous invocations. Provisioned concurrency guarantees that the execution environment is fully initialized and ready before the request arrives. This eliminates the initialization phase entirely for the provisioned capacity. We will detail the exact configuration parameters required to achieve this performance floor and maintain deterministic latency. Cold starts involve 3 distinct phases. First, the service downloads the code artifact from Simple Storage Service. Second, the execution environment is created, including setting up the networking stack, which is the primary bottleneck when the function resides within a virtual private cloud. Third, the runtime executes the global code outside the handler function. This includes static initialization blocks, dependency injection setup, and database connection pooling. Provisioned concurrency keeps the environment alive past this third phase. The environment remains warm, ready to execute the handler function immediately upon invocation, bypassing the entire setup overhead and ensuring immediate execution. Provisioned concurrency is a capacity reservation mechanism applied to specific Lambda function versions or aliases. When configured, the specified number of execution environments are kept perpetually warm. This capacity is dedicated solely to that function version. Unlike standard on-demand scaling, which relies on internal heuristics, provisioned concurrency provides a deterministic latency profile. The service charges for the time the concurrency is provisioned, regardless of invocation volume, plus standard invocation costs. The key metric is the guaranteed readiness of the runtime environment, ensuring predictable performance critical for synchronous application programming interface endpoints and user-facing services. Setting the correct provisioned concurrency level requires analyzing historical traffic patterns, specifically the 99th percentile of concurrent requests during peak hours. Over-provisioning wastes money. Under-provisioning results in cold starts for spillover requests. We implement application auto-scaling policies attached to the provisioned concurrency configuration. A target tracking policy is recommended, aiming for a target utilization percentage, typically between 70 and 80%. The scaling metric used is provisioned concurrency utilization, which measures the ratio of used to allocated provisioned concurrency. Define minimum and maximum capacity limits to manage both cost and potential traffic spikes effectively. Infrastructure as code mandates defining provisioned concurrency within the resource definition. Using CloudFormation, the AWS Lambda version resource must be explicitly defined, followed by the AWS Lambda provisioned concurrency configuration resource. This configuration must reference the specific function version or alias. For example, the provisioned concurrency config property requires the provisioned concurrent execution's integer value. If using aliases, the qualifier property points to the alias name. Remember that provisioned concurrency cannot be applied directly to the $latest version. It must target an immutable version number or an alias pointing to one, ensuring stability and controlled deployments. Since provisioned concurrency is billed per second, optimizing its schedule is essential for cost control outside of peak business hours. Implement scheduled scaling actions using application autoscaling. Define a scheduled action that increases the provisioned capacity before the expected peak load, for instance 8 a.m., and another action to scale it down to a baseline minimum, perhaps 0, after 6 p.m. This requires defining recurring schedules using cron expressions within the scaling policy definition. Always maintain a small baseline capacity if the service handles global traffic or unpredictable background tasks that require immediate response. Provisioned concurrency integrates seamlessly with deployment strategies using aliases. Define 2 aliases, say production and pre-production. When deploying a new function version, provision the required concurrency on the new version first. Once the environments are warm, use code deploy or manual traffic shifting to gradually route traffic from the old version alias to the new version alias. This ensures 0 cold starts during the deployment process. The provisioned concurrency configuration must be updated to follow the traffic shift, ensuring the capacity moves with the active version and maintaining continuous low latency. Effectiveness is measured by monitoring the provisioned concurrency spillover invocations metric in CloudWatch. A non-zero value indicates that incoming requests exceeded the allocated provisioned capacity, forcing a cold start for those specific requests. The goal is to maintain this metric at 0. Also monitor provisioned concurrency utilization to ensure the scaling policy is reacting correctly. High utilization without spillover suggests efficient use. Sustained low utilization indicates over-provisioning. Set up alarms on the spillover metric to trigger immediate alerts if cold starts are reintroduced, allowing for rapid capacity adjustments. Provisioned concurrency provides the lowest possible latency floor, but incurs continuous cost. For Java runtimes, consider Lambda snapstart as an alternative optimization. Snapstart reduces cold start times by snapshotting the initialized execution environment after the initialization phase. While snapstart is often cheaper, it does not guarantee the same sub-100 millisecond latency profile as provisioned concurrency, especially for functions with heavy virtual private cloud networking setup. Provisioned concurrency remains the definitive solution when strict, deterministic latency service level agreements must be met, regardless of runtime language or initialization complexity. To summarize the implementation strategy, always target immutable function versions, never the $latest qualifier. Implement application autoscaling with target tracking based on 75% utilization. Schedule capacity scaling to align with known business hours to minimize idle billing. Monitor the provisioned concurrency spillover invocations metric rigorously. Use weighted aliases for blue-green deployments, ensuring the new version is fully provisioned and warm before shifting traffic. Adhering to these steps guarantees consistent, low-latency serverless performance for critical application components and maintains service-level agreement compliance.